hi, hello, whatever you are feel connected with me. So today we are going to study a very interesting chapter of class 10 of your chemistry, that is metals and non-metals. So basically in this chapter, let me just give you an overview of this chapter. What we are going to study in this chapter? First thing, we are going to learn about their physical properties and chemical properties of metal and non-metal. After that, we are going to study about amphoteric oxide. We are going to learn about amphoteric oxide. We are going to learn about reactivity series. Then after, we are going to learn a very important, that is thermite reaction, which is used in welding. And we are going to learn about formation of compound by electron dot structure. And the last topic, which is your refining of metal and corrosion. So these are some of the topics which we are going to study in this chapter. So let's start by learning the physical properties of metal and non-metal. So students, basically you are aware about somewhere metals and non-metal. You studied in your previous classes about metals and non-metals. So I am making a table of metal and non-metal. So you studied in your previous classes that metals are hard. Metals are what? They are hard. And non-metals are soft. Metals have high melting point. Metals have high melting point. And non-metals have low melting point. You studied about metals are sonorous. Sonorous means it is a property of a substance. When we beat any hard surface, any metal surface, so they produce a ringing sound. So this is what called sonorous. So metals are sonorous. And non-metals are non-sonorous. Now, metals are malleable. What are malleable? Malleability is the property of a substance that can be beaten into thin sheet. So metals show the property of malleability. So they are malleable. Malleable means that can be beaten into thin sheet. Beaten into thin sheet. Examples, talking about metals, we take silver and gold. Non-metals are non-malleable. They are not malleable. Now the next property is ductility. So what is ductility? So this is the property of a substance that can be beaten into thin wires. When a substance converted into thin wires, this is called ductility. Example, we take silver, gold. So they are both ductile. Now, talking about non-metals, they are not ductile. As we already aware, metals are good conductor of heat and electricity. Metals are good conductor of heat and electricity. Good conductor of good conductor of heat and electricity. Electricity, metals like, and heat, metals like. In heat we take copper, silver, so they are good conductor of heat. And for electricity, similarly we take copper, because it is mostly used in electrical appliances, and it has a lot of uses. Parallelly, non-metals show opposite properties of metal, so they are non-ductile and they are poor conductor of heat and electricity. So I am erasing over right now, so we will understand the other properties also. Talking about metals physical state, so metals generally exist in their talking about their physical state. So metals are generally hard. Physical state, so they are hard. Talking about non-metals, basically we already aware non-metals exist in three forms: solid, liquid, gas. Solid, liquid, gas. In solids, carbon and silicon. Liquids, bromine. Gases, oxygen, neon. So non-metal exists in three forms: solid, liquid, gas, in three forms. But metals are generally solid. Not generally, basically they exist in solid state. There is an exception here about mercury. Mercury, which is a metal, exists in liquid state at room temperature. Here there is an exception here about mercury. Mercury is a metal, but it exists in liquid state at room temperature. Bromine is a non-metal. Make sure you remember this about mercury and bromine, because there is a confusion arises and many a times we got confused about this. So bromine is a non-metal and it exists in liquid state at room temperature. After reading these physical properties, a question comes in your mind that about metals, that they are good conductor of heat and electricity. So why always copper is preferred or it is used for electricity purposes? Why we don't use silver, gold? Even they are also good conductor of heat and electricity. Why don't we don't prefer gold and silver? The reason is that, students, copper is cheap. First thing, copper is cheap and affordable. Copper requires less maintenance and it has higher corrosive properties rather than if we talk about gold and silver. So that's why copper is preferred for the conduction in electrical appliances. So this is all about the physical properties. Now we're going to learn some of the exceptions which is in both metal and non-metals. These exceptions are very important. Many times lot of questions comes from the exceptions. So we studied about metals. Metals are good conductor of heat, electricity, they are sonorous, they are high melting point. So these are the properties of metal. So the exceptions are here, like first thing is alkali metal. Alkali metal, which is your lithium, sodium, potassium. They are soft. They are soft. They are very soft. These metals, lithium, sodium, potassium, these are very soft. They can even cut with a knife. They can easily cut with a knife. So this is the exception. Second exception is about lead and mercury. Lead and mercury are poor conductor of heat and electricity. These two metals are poor conductor of heat and electricity both. Third exception is about gallium and cesium. Gallium and cesium. Gallium and cesium. They have a very low melting point. Low melting point. So when you keep on your palm, gallium and cesium, when you keep on your palm, so they easily melt on your palm. So they have very low melting point. Now let's talk about the exceptions about non-metal. We studied about non-metals are non-lustrous, but there is an exception here about iodine. Iodine is lustrous. Lustrous means they have a shiny surface. So there is an exception here. Iodine is a non-metal and it has lustrous, shiny surface. Second exception is about diamond. As we already aware, diamond is a form of carbon. So diamond has high melting point and boiling point. High boiling point and high melting point. Third exception is about graphite. Graphite. Again, graphite is also a form of carbon and it is a good conductor of electricity. It is a good conductor of electricity. It conducts electricity basically. Good conductor of electricity. So these are some of the exceptions about metal and non-metal. Now I am erasing these. I hope you will note it in your notebooks. So there are some few exceptions also about copper and aluminium. Copper and aluminium. Copper and aluminium prefer and use in making utensils. The reason is that they are used in making utensils. There are three reasons for this. First thing is about heat, electricity. And they are corrosion resistant. Copper and aluminium are good conductor of heat, are good conductor of electricity, and they are corrosion resistant. So that's why they are used for making utensils. Now let me tell you about metalloids. Basically in NCERT it is not given properly. So metalloids are those metal and non-metal which show both the characteristics of metal and non-metals, so they are called metalloid. So basically those metal and non-metals which show both the characteristics, so they are called metalloid. So metalloids are your boron, silicon, germanium, antimony. So these are your metalloids because they show both the characteristics of metal and non-metal. Now so this is all about the physical properties of metals and non-metals. I hope you have understood this. Now let's talk about their chemical properties. So let's talk about chemical properties. So when metal react with oxygen, so metal oxide will be formed. Metal oxide will be formed along with heat. So whenever a metal react with oxygen, so metal oxide will form along with some form of heat also evolved. Let's take an example. Let's take potassium react with oxygen, so potassium oxide will be formed. When potassium react with oxygen, then potassium oxide will be formed along with heat also. Similarly, if I take sodium, when react in the presence of oxygen, then it will form sodium oxide along with heat. Let's balance these.